Sometimes we have multiple triangles attached to each other, and our goal is to solve for a certain angle or side length. And in these scenarios, we usually have to solve for multiple things before we get to our end goal. So let's look at our first triangle here on the left. So we have two right triangles stuck beside each other, and our goal is to solve for angle G. But if I look at the triangle FHG, the right triangle that angle G is in, I only have one side length. And I know if I want to solve for an angle, I need at least two side lengths, which means my first goal should be to solve for the height of this triangle, so FH, and then I can use SOH CAH TOA to solve for G. So my goal, I'll just label it as X. So I want to solve for that FH side length, which means if I want to solve for FH, I should first focus on my left triangle. So I'm going to look at EFH. I'm going to use 75 degrees as my reference angle. I'm going to label my triangle and solve for X. So X is actually going to be my opposite side. EH is my adjacent, and 6 is my hypotenuse, which means I want opposite and I have hypotenuse, so I'm going to use sine. So sine of 75 is equal to opposite x over hypotenuse 6. And like always, we're going to put sine 75 over 1 and then cross multiply. And when I do that, I get 1 times x equals 6 times sine 75. And when you do that in your calculator, you will get approximately 5.8 centimeters. So I'll go ahead and label that side length. And now I can look at the triangle on the right, and I'm going to label that triangle using G as the reference. So the 5.8 is still opposite, the 12 is adjacent, and the blank side is hypotenuse. And because I'm looking for an angle, I have to use two given sides. So I'm given opposite and adjacent, which means I'm going to use tan. So tan of angle G is equal my opposite over my adjacent. And anytime you want to solve for an angle, you're going to do the tan inverse, or whatever the trig ratio is. And when I do that, I get approximately 26 degrees for G. So it was a multi-step process because I had multiple triangles. So usually when you deal with these types of scenarios, you're usually going to solve for the side or angle that your triangles share, so that when you have all the information you need in one triangle, you can transfer it over to the next. Now, let's try our next example. In this triangle, our goal is to solve for x, which is the entire length of BD. So when you look at this, you might see the right triangle ABC right over here, and this triangle ACD that is not a right triangle. But if you look at the bigger picture, you also have another right triangle here. So you have the 40-degree right triangle and the giant 30-degree right triangle. So if I look at my big triangle, because I'm trying to find the base of that one, I have an angle, I have what I think is the adjacent side, and if I could just get either AB or AD, then I have enough information to solve for x. Now I have to think, what side do both of these triangles share? And they both share AB. So my first goal is to solve for AB in my small triangle. So if you want, you can label it with a letter, or you can just use AB. I'll just use AB in this scenario just to show you that you can do it either way. So using ABC as my triangle and 40 as my reference angle, AB, my goal, is opposite. I'm given the 6 centimeters, which is adjacent, and the blank side is the hypotenuse. So if I want opposite and I have adjacent, I'm going to use tan. So tan of 40 degrees is equal to AB over 6. So I want you to go ahead, pause the video, finish this off, solve for side AB, and then use the giant triangle and use 30 as your reference angle and try to set it up and solve for x as well. And then come back to check your work. All right, so hopefully for AB you got approximately 5 centimeters, which I have labeled in my triangle. And now looking at the giant right triangle where 30 is my reference angle, 5 centimeters is still the opposite. X is my adjacent, and this blank side, AD, is my hypotenuse. So I have my opposite as 5, and I'm looking for my adjacent, which means we're going to do tan once again. So tan 30 equals 5.0 over x, and then I can cross multiply. So hopefully you chose tan as your ratio. And in this scenario, we have to divide tan 30 from both sides to isolate for x. And when we do that, hopefully you got approximately 8.7 centimeters. And that's it for that example. All right, let's try our last one. So in this last triangle, we are solving for JL, which is this side right here. Now I only have 2 measurements, the 3 centimeters and the 4 centimeters, in this small triangle J or LMK. And I don't have any angles, so I'm probably going to have to solve for an angle. And if I look at this, I can see that angle L is shared with triangle LMK, this little one, which I have no problem solving for L. And then if I have angle L, I already have this 4 centimeters in this big triangle, JLK, and then I can solve for JL. So this one, it's a little harder to see the triangles because they're so embedded, but let's start off by solving for an angle. And if you see an example and you're not sure where to start, just solve for anything. Maybe it's going to be useless, but maybe it's going to be helpful. Don't just sit there staring at the question. Do something that you can use SOH CAH TOA on. So I want you to try to solve for angle L in triangle LMK. So pause the video, label your triangle, set up your ratio and solve, then come back to check your work. All right, so hopefully you labeled the 3 centimeters as opposite to L, adjacent is the blank side, and then 4 centimeters is the hypotenuse because it's directly across from that 90-degree angle. So that means we're using sine. So we're gonna have sine L equals 3 over 4, and then you would take the sine inverse of 3 over 4, and that would give you approximately 49 degrees. So now that we have that angle, now we can look at this big triangle here on the outside. I have angle 49, I have the 4 centimeters, and my goal is to find JL. So I want you to pause the video again, label this big triangle, maybe with a different color, where L is your reference angle, set up your ratio, then come back to check your work. So in this big triangle, the labeling has actually changed because now across from L is the opposite side, which is JK. Across from the right angle in our triangle, JL is the hypotenuse, and the 4 centimeters is now the adjacent. So here, color coding or erasing your previous markings is super important because we're given adjacent, we want the hypotenuse, we have the 49 degrees, so we're going to use cos. So hopefully you have cos 49 degrees equals your adjacent over your hypotenuse, which is JL. And now we can put cos 49 over 1 and cross multiply. So that when we do that, we have JL times cos 49 equals 1 times 4. Divide out the cos 49 from both sides to isolate for JL. And when you isolate, hopefully you got approximately 6.1 centimeters. So if you got that correct, great. If you messed up somewhere, check to see how you labeled your triangle, because maybe this one's a little harder to visualize. Maybe you have to turn your page around, use a highlighter, color coding, anything to help you visualize it better.